Hello, everyone, and welcome to the second session of our training series, Introduction to Remote Sensing for Tribal Lands. My name is Amber McCullum, and I will be joined by our project lead, Cindy Schmidt, throughout this series. For each week in this series, we are focusing on a specific tribal region within the United States. This week, we are focusing on the Navajo Nation, as we outlined during our first session on Tuesday. Just a few logistics and reminders about the series. We are providing the series via GoToWebinar each Tuesday and Thursday of October. From today, October 8th to October 29th. All of the course materials can be found at the United Tribes Technical College website shown here. And please refer to this website on guidance of how to review and submit your continuing education credits, and we can provide advice on that as well. Also, on this website, you will be able to find all of the lectures, the course exercises, and the data that you will need for the course. You should have downloaded all of the materials for session 2 of week 1. So this will be exercises 2 and 3 in order for you to follow along with our demonstration today. As mentioned before, this training series will be a mixture of lectures and hands-on exercises. All the exercises will be conducted in ArcGIS Pro, and we will demonstrate them in class. So we'll go through all the steps like we did last on Tuesday. We have some materials for ArcGIS Desktop and QGIS, but they won't be the focus of the series. So just as a heads up, you can use those software, but we won't be focusing on them. And again, here's the general overview of the training series. This week, we're really focusing on this introduction to remote sensing. And then next week, we will get into land cover class. Hello, everyone, and welcome to
folks,
the
it looks like
second
we're
session
experiencing
of our
some
series,
technical difficulties.
Introduction to Remote Sensing for Tribal Lands. My name is Amber McCullum, and I will be joined by our project lead, Cindy Schmidt, throughout this series. For each week in this series, we are focusing on a specific tribal region within the United States. This week, we are focusing on the Navajo Nation, as we outlined during our first session on Tuesday. Just a few logistics and reminders about the series. We are providing the series via GoToWebinar each Tuesday and Thursday of October. From today, October 8th to October 29th. All of the course materials can be found at the United Tribes Technical College website shown here. And please refer to this website on guidance of how to review and submit your continuing education credits, and we can provide advice on that as well. Also, on this website, you will be able to find all of the lectures, the course exercises, and the data that you will need for the course. You should have downloaded all of the materials for session 2 of week 1. So this will be exercises 2 and 3 in order for you to follow along with our demonstration today. As mentioned before, this training series will be a mixture of lectures and hands-on exercises. All the exercises will be conducted in ArcGIS Pro, and we will demonstrate them in class. So we'll go through all the steps like we did last on Tuesday. We have some materials for ArcGIS Desktop and QGIS, but they won't be the focus of the series. So just as a heads up, you can use those software, but we won't be focusing on them. And again, here's the general overview of the training series. This week, we're really focusing on this introduction to remote sensing. And then next week, we will get into land cover classification. The following week, we will focus on change detection and time series. And then the last week, we will focus on remote sensing web tools. So for today's session, we will learn how to download Landsat imagery from a data portal called Earth Explorer. And I will highlight some other places to find NASA imagery through the lecture. We will also discuss spectral indices and their application for understanding Earth processes. Finally, we will focus on the Normalized Difference Vegetation Index, or the NDVI, that is a specific spectral signature that we use to evaluate vegetation health. So we're going to start with a brief lecture of the data portals and spectral indices. Then we will walk you through two of the exercises. So again, just make sure you have all the materials downloaded for today, and you can follow along with us today, or you can complete the exercise on your own. So first, we are going to start off reviewing data portals and how to access Landsat imagery. Web portals are all the places where you can access, download, and sometimes analyze remote sensing imagery. All portals for NASA data are freely accessible. Some portals, such as those provided by the U.S. Geological Survey, allow you to subset the data for a very specific area of interest. And some, you can even visualize the data and conduct initial investigations of the data prior to downloading. They are all designed for real-world applications of the data. Finally, some portals, such as Google Earth Engine, do not require you to download the data and allow you to conduct analysis through their cloud computing software. There are some limitations to be aware of, however. In some cases, when you are doing visualization or analysis on a portal, you may not know what's going on behind the scenes, such as atmospheric correction or any kind of pre-processing, really. So you have to be careful to understand what's going on behind the scenes when you download or access the imagery. Similarly, there is less direct use and analysis of the data by the user in some cases. So that can lead to uncertainty sometimes. Also, for some portals, you may be limited by the time period or coverage or type of data of interest. And all of these portals require an internet connection, and in areas of low bandwidth, processing and downloading can be time consuming. In the final week of this training, we will focus specifically on web portals, so we'll come back to some of these concepts later on. Today, however, we will focus specifically on downloading Landsat imagery. There are a lot of portals where you can obtain Landsat images, and I think there are multiple websites where you can find sometimes the same information. This is oftentimes confusing because many of the sites function in a similar manner. In general, people tend to use the sites they're most familiar with. However, it's probably a good idea to take a look at the various places where you can obtain these data and see which you prefer in regards to the way the data are visualized and how you can download the imagery. Here are a few examples where you can obtain Landsat. First, Landsat Look Viewer. Second, Glovis. Third, Appears. And finally, Earth Explorer, which is what we'll use for our exercise. It's important to note that Landsat images are referenced to areas on the Earth using something called the WorldReferencing System. This system, with the flight lines for Landsat, are shown here. So you can see the red colored lines are essentially the flight lines for Landsat and where it's traveling and where it's obtaining data. So what you can do is for each Landsat image, you can search for it by the path, which is the vertical lines, or the row, which is the horizontal lines. Once you get to know your region and become familiar with searching for these paths and rows, this will make a lot more sense. These reference values are also noted in the naming convention for Landsat. Here's a more zoomed in view of what the Landsat scenes or areas look like. So the boxes essentially show one scene of Landsat, and you can also see that they overlap in a lot of places. So in some regions, you may be able to obtain an image from different, you may be able to obtain multiple Landsat images for your area. During the first exercise, we reviewed the Landsat naming convention. And here it is again. Let's sort of talk through it a little bit more because it is really important. The first letter is for Landsat, or L. The second is the instrument type. In this example, this is a combined optical and thermal product. You can also obtain the Operational Land Manager, or OLI, that contains all the visual and near-infrared bands, or the Thermal Imager, which just contains the thermal bands. Next is the Landsat number. Here it is Landsat 8, but it could be 5 or 7, just depending on which Landsat the image came from. This could also depend on your time period of interest. Next is the path number and then the row number. The path and row refer to that WRS, that reference system that we just discussed. And the paths are sequential numbers from east to west, and the rows are the latitudinal center of each scene. Next is the year when the scene was acquired, and then the Julian day. Often NASA data are referenced using Julian days, and you can find the conversion into month, day through a simple Google search. Here, 76 refers to March 17th. Next is the ground station where the data were received. Then you have the archive version number. In our scenes, you will obtain multiple TIFF images that are each banned separately, and we looked at those in the first exercise. If you download the data in this manner, you will also see the band number at the end of the Landsat name. Now, just a quick review of some of those specific Landsat portals I mentioned. All of them house Landsat imagery, and some contain imagery from different satellites. The Landsat Look Viewer is a tool that was developed to allow for rapid online viewing and access to the USGS Landsat Image Archive. Within the viewer, you can interactively explore Landsat Archive, search for specific Landsat images based on your area of interest, acquisition, or cloud cover. You can compare images and view changes through time. You can display different map layers that are underneath your image. You can look at the metadata. You can also search by a very specific place or by a path and row number. And you can also generate an animation of the oldest to the newest images if you're interested in sort of getting a quick look at how the land is changing over time. Another place for accessing Landsat data is Glovis. The USGS Global Visualization Viewer, or Glovis, has been available to users for accessing remote sensing data since 2001. It was redesigned in 2017 and now allows you to narrow down results by identifying your parameters in the panel on the left. You can view multiple scenes at once. You can view the metadata and download the full band source imagery. And you can customize many of the features to your preferences. And as I mentioned, with many of these portals, it really just depends on your interests and which portal you like using the most. I will say that all of these portals, in order to download imagery, you have to sign up for a free account. We'll talk about that when we do our exercise today. The Earth Explorer is the data portal that we will use for our exercise. And it's a really like a one-stop shop for obtaining data for many different collections. So not only Landsat, but there are other data available, such as radar data here, as well as Sentinel data from the European Space Agency. So you can search by an exact location via the interactive map, or input specific coordinates to view which data types are available. I also wanted to mention the application for extracting and exploring analysis-ready samples, or APIRS. And APIRS offers users a simple and efficient way to perform processes on the data prior to downloading. So you can do things like subsetting spatially, temporally. You can look at time series of data and sort of analyze these things prior to the download process. So you can submit request to analyze the quality of the data. And you can look at point samples or area samples. And you can do this with MODIS and VIIRS as well as Landsat data. And you can create these visualizations in the tool prior to your download here. It's a really great tool. Google Earth Engine has some incredible functionality. You may have heard of it. So you can access many of the NASA data sets through their collection archive and conduct analyses all within the tool. So you can do things like calculating vegetation indices that we'll do today in ARC. You can do many of those simple processes in Google Earth Engine too. It's also free to sign up, but you have to be approved, which usually takes about a day. And you have to use coding in order to do this. So that's maybe a limitation for some folks who may not be very familiar with Java or Python. Climate Engine harnesses the power of Google Earth Engine, but it provides information in this user-friendly interface. So it has a variety of data sets like Landsat and MODIS. And what you're seeing here is the NDVI value for an agricultural region in Brazil. The cool thing about Climate Engine is you can evaluate statistics and select different time periods. You can also select a specific region by drawing a polygon and then downloading just the data for a very specific region. What we're going to do in week 4 is explore our Navajo Nation spin-off tool that is a spin-off of Climate Engine. So we will be playing around with a lot of these functionalities in our week 4 exercise. Okay, so now we're going to briefly discuss spectral indices, in particular, the NDVI. A spectral index is created using a ratio of the bands of an image and relates to how the land surface features, reflects, or absorbs energy within those wavelength ranges. It's a simple mathematical expression that highlights these reflectance properties. It's also helpful to use a spectral index to reduce the effects of the atmosphere and potentially aspects of the sensor. It can also be applied across space and time for multi-temporal comparisons. There are many uses of spectral indices, and we'll talk about those today. They can be used to assess things like vegetation health, burned area mapping, water content, biomass of forests, and for geologic mapping. So we will focus on the Normalized Difference Vegetation Index, or the NDVI. As you recall from our first session, When sunlight strikes plant leaves, the chlorophyll in those leaves strongly absorbs visible light. So absorbs blue and red. And the cell structure of the leaves reflects green and strongly reflects near-infrared light. This is portrayed in the graphic on the top as well as in the graph. So the two key wavelengths for the NDVI are the red and near-infrared. In the graph, you can see where the red is being absorbed here and where the near-infrared is being highly reflected. NDVI is the relationship between the red and near-infrared wavelengths. And you can see the actual formula here. The values of NDVI for an individual pixel will range from -1 to 1. Any pixel between -1 and 0 means no vegetation, and pixels closer to 1 indicate highest possible density of green leaves. The picture on the right shows that healthy green vegetation absorbs most of the visible light, only about 8% is reflected, and reflects a large portion of the near-infrared light, with about 50% being reflected. Unhealthy, sparse, or senescing vegetation reflects more visible light, about 30%, and less near-infrared light, about 40%. You can see the differences in the resulting NDVI values here. So green vegetation is a value closer to 1, while brown vegetation has a value closer to 0. The NDVI is one of the most widely used vegetation indices in the world and has been used to assess vegetation over multiple areas and for different resolutions as well. Vegetation health is generally a measure of the amount of reflected near-infrared light that we've discussed. It can also be used to better understand phenology of plants through the year. So it's really useful for farmers to improve agricultural production and manage water resources. Using average NDVI values in a particular region, periods of reduced plant growth relative to the average can be assessed. So this might be related to drought conditions where we have less rainfall. This image here is an example of NDVI from MODIS. And here you can see the darker the green area, the higher the NDVI value. And that is where most vegetation is present. So this is in Arizona, showing you the really vegetated region just south of Flagstaff. And this image was acquired through a different tool created by the University of Arizona called Drought View. So you can look at these changes in vegetation over time, for example. NDVI is also useful for plant phenology. Phenology is the annual dynamic of vegetation greenness and essentially shows you how the seasons change. And this example is from North America. So you can see earlier in the year, which is winter, there are little to no leaves on the trees, resulting in low NDVI values. When spring arrives, the vegetation greens up and NDVI increases until it peaks in the summer. Then, as vegetation senesces and the trees lose their leaves, the NDVI values decline. So the two images on the bottom here show you the NDVI values in the winter versus the summer. NDVI anomalies are often used to show current vegetation patterns relative to long-term averages. This can be calculated by subtracting the long-term mean from the current value and is oftentimes done on a monthly basis. For example, if the anomaly is negative, this indicates that the vegetation is less green than normal, which may be indicative of drought-like conditions. You can see this with the images here along the bottom from the southwestern US, where in the early 2000s, there was a large-scale drought appearing, as you could see with the red colors indicating drier or less vegetation. This table summarizes the differences in the band numbers between Landsat 8 and the other Landsat sensors, 4, 5, and 7. So the red and near infrared bands, which are the ones that we will use for NDVI, are bands 4 and 5 for Landsat 8 and bands 3 and 4 for Landsat 4, 5, and 7. It's important to know these when we conduct the exercise, but we'll review which bands those are when we do that. So there are other indices that are useful for vegetation and other analyses. One such is the Enhanced Vegetation Index, or EVI. EVI is another measure of vegetation health. It's particularly useful in regions with high biomass because the NDVI can oversaturate or essentially hit a maximum value in regions like the Amazon, where the EVI has a higher threshold and can identify more subtle differences in the vegetation in this region. So it uses a few different constant values, as well as the near infrared, the red, and the blue bands. The Normalized Difference Moisture Index, or the NDMI, uses the shortwave infrared band, which is more sensitive to water within vegetation. Thus, it can detect subtle changes in vegetation moisture and is a good index to evaluate drought. This can also be used for identifying fuels in forests to determine susceptibility to large wildfires. The Soil Adjusted Vegetation Index, or SAVI, minimizes the influence of bare or nearly bare ground when trying to assess vegetation. This one can be used in arid and semi-arid regions like the Navajo Nation that we'll focus on, where there's greater bare ground or soil cover in the region compared to the vegetation. Here, the near infrared and red bands are used, but we have a correction factor applied. The Normalized Difference Snow Index is useful to determine areas that are covered with snow, and it uses the green and shortwave infrared bands. When the NDSI value is at 0.4 or above, we have confidence that there is snow in this location. The challenge with NDSI is that because snow is highly reflective, it's oftentimes confused with clouds. But we can see here an example of snow on a glacier using this index. Finally, the normalized burn ratio is used to identify areas where vegetation has burned recently due to a fire. This is a ratio of the near infrared and shortwave infrared bands. The NBR can also be used for identifying changes in forests, such as those related to logging. So here you can see images of pre, during, and post-fire from a large complex that burned in California in 2018. And the red areas that you see outline the burn from the area impacted by the fire. So with all of these spectral indices, we are really examining the differences in land surface types and how they reflect or absorb energy at different wavelengths. Here you can see this really clearly. So when we think about the NBR, we are interested in the difference between healthy vegetation, which has this large peak in the near infrared, and soil or burned areas, which are much lower in the near infrared. Then as we move across the electromagnetic spectrum, the healthy vegetation has low reflectance in the shortwave infrared, but the burned areas have high reflectance in those wavelengths. So by using the difference of the ratio of these, we can identify burned versus non-burned areas. These relationships can also be useful if we calculate the NBR prior to a fire and then after a fire, and then take the difference between those images. So using this kind of approach shown here, we can assess the severity of the fire. So we can assess how severely the vegetation was burned. And you could see a map here from the station fire for this example. Okay, so that concludes our overview of web portals for Landsat and spectral indices. So now we're going to jump into the exercises. And as I mentioned, we have two for today. First, we're going to go through a demonstration of downloading your data from Earth Explorer, and then we will be calculating the NDVI using Landsat imagery. And also, just to mention, next week, we will be moving on to land cover classification, so do please join us then. All right, so give me one moment as we transfer over to our exercise, our demonstration for today. Okay, for this first exercise for today, we will be accessing Landsat data through Earth Explorer, which you can see now on my screen here. So all you need for this exercise is just your internet browser and some space on your computer to actually download the imagery. So as I mentioned, Earth Explorer is one of the primary places for you to access Landsat data. And before you actually are able to download data, you have to register for an account. So what you can do here is right along the top, you can go to login, and you can actually register, create a new account. If you don't have an account already, I already do, so I'm going to sign in. When you create an account, you'll receive a confirmation email, and then shortly thereafter, you'll be provided access to the website. So it doesn't take too long for them to approve you, but you'll get an email confirmation of your account. So once we're here, we start off by centering on Sioux Falls. And this is actually where the Land Processes Distributed Active Archive Center, or LPDAC, the USGS arm that houses these data portals and tools, they're located in Sioux Falls, so that's where we start. Within Earth Explorer, you can see the search criteria here along the top is divided into 4 parts. So we have the general criteria, data sets, any additional criteria, and then we'll see the results along this panel as well. So what we're going to first start with is, because we're still focusing on the Navajo Nation, that's where we're going to zoom into. And we've provided you with the path and row for the region surrounding Window Rock, Arizona. So what we're going to do is we are first just going to define our path and our row. So here, what we are going to do is we are going to select a path and row. Again, here you could type in an address or a place and it'll take you directly there. But we're interested in the path and the row because we know it offhand, because say we've been doing analysis in this region for quite a while. So here we're interested in path 35, row 35. And now you can see we've zoomed in here and we're centered on the Navajo Nation area. Right here over Window Rock. So it's added these degrees of latitude and longitude here. Now we are going to decide on the date range. And what we are going to look for is September 1st, 2016 to October 1st, 2016. Now, if you're just initially looking for imagery, you probably want to make your time window much larger because of the infrequent time of Landsat, the overpass, and the potential for clouds in your area. But since I know we have a nice image within this time frame, we're going to just specify this. You can also change the search months. If you're only interested in, say, summertime data, you can do that, but we're just going to keep this as all. So we'll click on data sets next. Now, you can see here along the side that there are many different data sets that we can choose from. We are interested in Landsat. And we are going to click here on Collection 1. And then Collection 1, Level 2, on demand. And we are interested in Landsat 8. You may get this default message that says that the thermal and panchromatic bands will not be included, and that's okay, because we are interested in the visible and near infrared bands for our next exercise. So now that we've chosen our data set that we're interested in, we can do some additional criteria. And I always recommend doing this because cloud cover is a persistent issue with imagery. And if you're interested in the land surface features, you do not want clouds. So I always recommend that we take a look at our scene cloud cover. So if we click on the plus here, we can add this filter. And we can say less than 20%. Because honestly, if you have more than 20% of your image taken up by clouds, it's probably not going to be a very useful image, especially if you're interested in analyzing a large portion within that image. So 20% is oftentimes recommended. So now along the bottom here, we can click on results. Before I do that, I do want to mention that there are a lot of different filters or additional criteria that you can take a look at, but we're just going to be interested in the cloud cover here. So now if I click on results, I'll wait for a moment, and what I'll see here is the specific image that we want, because I was so narrowly focused on the time window as well as the cloud cover that I was taken right to the image that I want. Again, if you select data over a longer time period, you'll probably have many different images to choose from that'll be listed here. But what you can see here are a few different things. You can see the ID. So that's the essentially the image ID that we reviewed in the lecture. You could see the acquisition date and then your path and your row. There's a little thumbnail here, and then there's some more information along the bottom. So you can do things like show the footprint, which will identify the outline of where the image is taken. So that's the area over which your Landsat image will be available. You can also do things like show the browse overlay and compare if you want to compare some of the images. And then you can order the scene or add it to your cart, which we'll do in a moment. But if you first just click on your little icon here, your little thumbnail, you'll be shown a larger image, larger picture of your Landsat image, and then you'll have some information about the data. So the metadata, as we call it. Again, the ID, the path and the row, which is important, and then some other information about the time, the cloud cover, and some other information here. So it's always a good idea to kind of take a look at it a little closer. You can also see in the image that we do have some clouds down here. We'll deal with those at a later date or a later time, but it helps to really visualize the image prior to downloading it. Okay, so we can close that little pop-up. And what we're really now interested in doing is downloading the bands of this image, right? Downloading all of the image information. So it's sort of like shopping on Amazon or whatever online shopping that you're doing. You click on your shopping cart, and once that is highlighted with green, that essentially means that the item is in your basket. So then you can click on view item basket, and you can get the information about the data that you're about to download. The Earth Explorer now has this on-demand processing. So some products require some additional time for processing, but these usually you acquire them pretty quickly after you order them. You will get a confirmation email when you submit your order, and then for me it's generally a few hours if you're doing it during a weekday that you can expect to actually get another email that includes the link to download the imagery. So let's just start the order here. And what you can see here now is just double checking what you've ordered. If you have placed a lot of images in your cart, you'll have many different images here, and you can turn them on and off if you may or may not want some of them, just like a shopping cart online. And so we know that this is our Landsat 8 image for our specific date on September 16th, 2016. We know that because that's the acquisition date here that's identified. And if we're all good to go here, we can submit product selections. Then you will receive this confirmation, and you can check your email to ensure that you receive the confirmation email. So as I mentioned, generally within a few hours, you will receive a second email that takes you to a link where you can download the imagery. And for that link, you'll download the imagery as a zipped file, and then you'll have to unzip that on your computer in some way, shape, or form. So you can use 7-zip or some kind of similar program for that. And then you'll see the folder with those multiple bands like we looked at in our first exercise. So that's a very brief, simple introduction to how you can download Landsat imagery. And I really encourage you to come take a look at Earth Explorer and play around with it a bit more, particularly for your region of interest. And take a look again at the cloud cover and how often you can obtain imagery, and you can run these similar analyses that we'll do throughout this course on your area as well. I really like Earth Explorer. I feel like it's one of the easier tools to use, so I do always recommend them. We have also included some information on the Glovis platform, the Global Visualization Viewer, within the exercise. We won't actually go through that in the demonstration, but that's another great place to obtain imagery. Very, very similar to this, but there are some key differences that are important. So if you're interested in taking a look at Glovis too, that might be another good place to go. All right, so that concludes our exercise 2. That was a really short one, I know, but it's pretty straightforward, simple way to download Landsat imagery. So now, if you just give me one more moment, we will pause again and we will get started with exercise 3. Okay, so now we're moving on to exercise 3, calculating NDVI using Landsat imagery. We are doing this exercise in ArcGIS Pro, so go ahead and start up Pro. I have it pinned to my taskbar. I just like to have it there. Start it up. You can also search for it if you need to. Once ArcGIS Pro is ready to go, we're going to create a new map. For this exercise, we are going to be calculating NDVI, and we're going to be using our Landsat image that our composite image that we created during exercise 1. So hopefully you all completed that portion and you have that file ready to go. And we're also going to be using a shapefile of the Navajo agencies. So outline of the Navajo Nation that we will be using to essentially clip our imagery for analysis. So the first step will be here is to create a new map. We are going to name this project NASA IP EX3 for exercise 3. We are going to navigate to our exercise 3 folder. Mine is located here on desktop, and then week 1 and exercise 3. And just make sure that you're saving everything to the right folder and you have everything organized well. That'll help as we move along. And then click OK, and what'll happen is you'll start to create a new project and a new map will open. Also, the default for ARC is to have this world topographic and world hillshade map included. You can keep them on for now. We may be turning them on or off as they do sometimes slow down your ARC map. So up to you if you keep it. It's nice to have it for some contextual information to make sure we know where we're located in the world. But we'll keep it for now. The next piece that we will do is view our catalog pane. If you don't see your catalog pane here on the right, you can simply go to View and click Catalog Pane. And what we're going to do is essentially first is add that composite Landsat image. So what we'll do here is come to Folders. If you click on your down arrow, you'll just see that you are connected to essentially the folder for this project, but we want to get to our first project folder. So if we go to Add Folder Connection, come in and find where your folder is for this entire training series. And I'm just going to connect to the entire top level folder so that I can access all the information within it. So then click on OK. And now what we're going to do here is come to NASA IP, for my example, week 1, exercise 1, and just clicking the down arrow so that we can see what's within these folders. And then you will see here, I have my Landsat exercise 1 TIFF. And this is the thing that we want to add to our map. So I'm just going to right click and click Add to Current Map. And now it looks like nothing is happening, but this might take a moment for it to load. The first time I did this in practice, it took a little longer. But now what you can see is our composite Landsat image with all 7 bands included. And you can again see that it's located right here over the Navajo Nation, where you can see the Chusca Mountains and the area here just south of Farmington is actually the area that we'll focus on today. As we did in the first exercise, let's just adjust our band combinations. So you can come here and right click. This is the quick and easy way to do it. You can also come here and right click on the image name and go to symbology. I'll just do it right here in the contents panel. So I'm just going to change this to our combination of 653. So 6 is the shortwave infrared, 5 is the near infrared, and 3 is the green band. So we'll see what that looks like. If you remember from first time, we'll do 6, 5, and 3. So this is our band combination that really highlights the green vegetation, really pulls out that green vegetation because our near infrared band is in the green, and then we have the shortwave infrared in the red. So the vegetation really pops here, looks really nice. The next thing we're going to do is add our agency shapefile. So we still have our catalog pane open. I'm just going to close the exercise 1 folder so that we can see it a little more clearly. And then I'm going to open the exercise 3 folder. And we will see here that our agency shapefile is located here. So what we want to do is we want to add the agency.shp. And again, you may notice that some of these files have like the dot and the dash at the beginning of the name. You don't want to add those. So make sure it's just this agency.shp. So again, we're going to right click here and we're going to add to current map. Now, what you can see is we've added the shapefile of the Navajo Nation. If we want to see the entire file, again, we can right-click and go to Zoom to Layer. So now you can see this pink outline. This is the area of the Navajo Nation that's overlaid on top of our Landsat imagery, as well as our base maps. So the pink color is maybe not so useful for us. So we're just going to come in here and right-click on the agency shapefile and then go to Symbology and just modify this slightly. We can change our catalog, where we can close our catalog panel to clean this up a bit. What we are going to do is we're just going to create a black outline so that we can see underneath of our imagery. But if we just click there right on that symbol, the very first option will be a black outline 1 point. So that's what we want to choose. So we can just see now here the outline of the Navajo Nation, but we can see the imagery underneath of it. So it's a transparent fill. So that's our very first option that we have here. We can go ahead and close the property, the symbology option, and just take a nice look here at our image. So the next thing we're going to do is we are going to clip the Landsat image to the area over which the data are located within the Navajo Nation specifically. One thing you might notice is that much of these clouds here are actually outside of the Navajo Nation boundaries, so that'll be nice because we'll be getting rid of these little cloudy patches that may disrupt our image a bit. So what we want to do here is come up to the Analysis tab and click on our Tools icon. And then we have the handy search function, and we can just type in clip. Now, it's very important that we use the clip raster option under Data Management Tools. So we click on that. And now we can input all of the parameters in order to complete this process. So for our input raster, that's just going to be our Landsat image. So click on the down arrow, select that. The output extent is just going to be our agency. That's the extent over which we want our Landsat to be clipped to. Now, it's important that we click on this Use Input Features for clipping geometry, because that essentially tells us, use this agency extent. Now, under Output Raster Dataset, we are going to want to make sure that we navigate to our Exercise 3 folder. And we are going to go ahead and name this Landsat clip. And because I have practiced this exercise a few times, I'm just going to add 2 here on the end to make sure I am creating a new image. You don't need to do that. And make sure, however, that you do include your .tiff extension. Otherwise, it may save it as a grid file or some other format here. Now click on Save. And the final thing we're going to do is change our no data value to 0. So double check that your window appears just like this one. And then we're going to click on Run. And you could see the progress happening below as we clip our raster to this extent. And this may take a few minutes, and that's all right. Just be patient with it. Again, depending on your network speed, this may take a few minutes. Looks like it's running pretty quickly for us here. It's a pretty simple process. But once it finalizes, what we will see is our clipped Landsat image will appear in our contents panel on the left. And this is not a requirement for calculating the NDVI, but I do recommend down selecting to a smaller region. This will help with processing time. This oftentimes helps eliminate clouds. Other issues you may have, especially with pre-processed Landsat imagery, is that sometimes the image will be over-processed. What's done with a lot of the pre-processing at these data portals is they account for, they do an atmospheric correction. And sometimes they do some accounting for like doing a cloud mask, for example. In some cases, the correction factor can be too high and can create some kind of reflectance issues when you're calculating your band ratios. So clouds are always something I just like to get rid of if I can. Folks who are interested in, maybe analyzing aerosols or precipitation may disagree, but that's generally my take as somebody who's interested in the land surface processes. Okay, so what we can see here now is that we are going to go ahead and close our geoprocessing tab here so we can, again, take a nice good look at our image. And what you'll see is I have my Landsat clip here that's added to the contents panel. You can see it kind of looks grayscale because it does this 1, 2, 3 as opposed to our 5, 6, 5, 3 option here. So it looks like this process ran properly. So that is great. Now what we're going to do is we're just going to remove our, either remove or deselect. I'll leave it up to you all, but you can just turn off your Landsat image and you can turn off your agency. And what you'll see here, the other thing that you can do that's really nice is right click on your Landsat image and zoom to layer, and that'll just take you into the full extent of that layer. So what you can see here now is we didn't cover the entire Navajo Nation with this one scene. We would need many Landsat scenes to do that. But within our Landsat area, we've clipped out the regions outside of the Navajo Nation. So you can see here the boundaries of that agency shapefile here. We can also just take a look at where we are oriented in space if we want by turning the image on or off in the panel here, but we're interested in this clipped image now. Let's go ahead and change our band combination to the same one we did for the initial composite image. So we're going to do 653 again. So we're making that vegetation pop here. And you can zoom in to take a closer look to some of these regions by just using your mouse, or you can do zooming here. You can double click on the map to zoom in sometimes to a location. But yeah, take a look at your image. You'll notice some major features that pop out, like the Chippewa Mountains here, highly vegetated region, and a highly agricultural region just south of Farmington here. So be sure to save your map along the way. I'm a huge proponent of saving your project. Takes a second, may save you a lot of time in the future if something crashes. Okay, so that was part 1 of the exercise for those of you kind of following along. The next part is going to be calculating that NDVI, the sort of the big takeaway here. So the very first thing to do is, let's go ahead and zoom to layer again. So we're just looking at this whole region. First, we need to double check to make sure your spatial analyst extension is activated. This is really important for doing almost any kind of raster analysis, in particular, the raster calculator that we'll be doing for this vegetation analysis. So if we click on project, we can then click on licensing. And here where you see Esri extensions is where you're going to see your spatial analyst option. So we just want to make sure that we have spatial analyst. Here it looks white for me, license, yes. And that all looks good to go. If it's black and it says no, you need to click on configure your licensing options and then check the box next to spatial analyst and click OK. So you would click here and then you would see your licensing type and you would be able to just double check to make sure your spatial analyst is checked on. We'll give this a moment to check our licensing type. So again, here you can scroll down and see, okay, we have it checked. That might be the only thing that you need to do. If you don't have spatial analyst at all and you don't have those options, that may be an issue with your license. You may not have spatial analyst included in your license. That's something that we can't help you with, but it's just a heads up that you will need that for running these analyses. So click OK here, and then just come back to your project. We're good to go. Our spatial analyst is turned on. If you don't have it, it's not turned on, you won't be able to run the next steps. Okay. So although we are already displaying our composite clipped Landsat image, what we're going to need to do is just add specific bands of this image because those are the specific bands we will use for our NDVI calculation. And as I mentioned, bands 4 and 5 for Landsat 8 are the ones that are the ones will be being used. So again, we're going to have to click on View and take a look at our catalog pane, and come over here and find our clipped Landsat image. So we're actually going to go to exercise 3 now, and we have our Landsat clip. And what we're going to do is just add bands 4 and 5, so the red and the near infrared. You can do this by clicking on one and then clicking Shift and holding them both down, and then right-clicking and go to Add to Current Map. And also, if you all are having issues, questions along the way, do feel free to type those in and let us know. We'll have time to answer some questions along the way at the end as well. But just a heads up here, if you're feeling really lost, no worries. If you missed a step along the way, not a problem. We can come back and answer any of those questions that we need to. And I believe, as Cindy mentioned during the first session, sometimes our processing is a little slower. Just the way our license is designed, we essentially share a license across our branch for our agency, and so sometimes these steps go a little slower than you may be experiencing. So you may be ready to go, but we'll just give it one more moment here. And there we go, patience. Okay, so now what you'll see is a grayscale image of bands 5 and 4. And what I'm gonna do, just for processing time to save me a little bit, is I'm gonna turn off my, my base maps. You don't necessarily have to do this step if yours is going nice and quickly. So what we're going to do now is we can close our catalog pane, focus just on this region again. And the next thing we're going to do is use a tool called the raster calculator. So we've moved on to part 3 of the exercise. We are again going to come up here to analysis, click on tools. And what we're going to search for is raster calculator. And this is an image analyst tool. It should be the first thing that comes up. So we'll just click on that. Now this may look a little different than some of the other tools that you've seen. So let's just kind of talk through this for a moment. So what you can see here are the rasters. So these are each of our images in our contents panel that we will be able to use for our mathematical expression of the NDVI. Along the left, or along the right, excuse me, there are different operators. So we'll see essentially pieces of a mathematical equation that we can use and add and include. So, you know, plus, minus, multiplication, division, all these different operators. We can also create conditional statements. So we won't go through this in our training here, but those are some options that you have. You have some mathematical expressions like absolute value, exponent, things like that. One thing that will be very important for what we do is this tool called float. What float allows us to do is it allows our new image that we create to have decimal points. So we always want to use float, especially when doing a vegetation index calculation, because those values are going to be between -1 and 1, and they're all going to be like a decimal point value that we're interested in. So that's going to be really important to include as well. All right, so once you click on these things, what you'll see here is your mathematical expression will be generated down here, and then you'll be able to save your output raster. So let's just go through and create this equation. So as I mentioned, float is important. The very first thing we want to do is double click on float, and then you'll see that added down here and below. So refer back to your exercise document, refer back to the notes that we have. The equation for the NDVI is essentially what we're going to type in here. So it's going to be bands 4 and 5, the red band and the near infrared band once again. And the calculation is going to be the near infrared minus the red divided by the near infrared plus the red. So let's go ahead and do that. So again, our near infrared band is band 5. So we'll just double click on 5 here. Now make sure you go back inside the parenthesis, because you'll automatically be taken outside the parenthesis, and then come back up to your operators and double click on minus. And then we are going to subtract band 4, the red. Now go outside of your parentheses, and we're going to use the division symbol here. So double click on that. And again, we're just going to use float again so that we have the ability to express our values in decimals. So double click on float, and then we're going to double click on band 5 within the parenthesis, go back up to your operators, and now it's band 5 plus band 4. Oh, go in my parenthesis here, plus band 4. Okay. Double check to make sure your expression looks exactly like this one. When you have a mathematical expression that makes sense, you won't see this little X, red X up here. If you see a red X up here, something is wrong with your equation, and you need to double check it. So you can double check by looking at this video, you can double check by looking at your exercise, either way. Now, before we click run, we want to navigate to our exercise 3 folder and save our raster. So here we're going to call it Landsat NDVI. And again, I'm just going to use the 2 because I've done this before. I don't want to come up with any error for you, but you can just call it Landsat NDVI.TIFF. T-I-F. And then make sure you're in your exercise 3 folder here. Now you can click on save, and then you can click on run. And as we've seen with our other processes, this may take a few minutes. What essentially is happening behind the scenes here is really cool. For every single pixel of these images, it is running this calculation where it's calculating this ratio between the near infrared and the red bands. So there's a lot happening behind the scenes, and this can take a few minutes for you. So please be patient with this, and we will just allow this process to run. Okay, fantastic. Our raster calculation has been completed. The new Landsat image has been added to the map, and we can see that here along the panel here. So let's go ahead and close our raster calculator. Now, what you can see here is our values range between -1 and 1, which is great. And now these represent our NDVI values, or our measure of vegetation health. The color scheme here, the black to white, is not super helpful. So let's go ahead and change up this color scheme. So we will go ahead here and right-click on our image and then go to Symbology. And what we're going to do is change the primary symbology. It's stretch right now, but we would like to use classify. Now we'll leave this method, the natural breaks method, selected, and we will change this to 10 classes. Now we have this sort of yellow to red color scheme that maybe isn't super indicative or helpful for us to think about vegetation. So we'll change the color scheme. And if it's helpful, you can turn on show names. That's sometimes very helpful for me. And what we'll do is like scroll through and take a look at the different color schemes available. And what we're going to look for is our red to green continuous, which is actually towards the bottom. Here. Red, yellow, green, continuous. Now what we'll see are the reds or lower values are less vegetation, less healthy vegetation, and the greens are more healthy vegetation. So that's sort of better conceptually for us to think about. So that's a good color scheme to use. Now, one thing you will notice is that if you take a look at the values here, the very first symbol or very first color category is actually values that are negative. And negative values are generally indicative of things like water. So what we can do here is come in and change this color to blue to help indicate water. So we can come down here, just click on that red color and change it to a blue. And you'll notice that when we take a closer look at our NDVI values. So go ahead and change and close the symbology. If you zoom in to this agricultural region here, you'll see what I'm talking about with the blue. So the blue that you see here is actually a lake. So you can zoom in and out of the image and explore some of these features that you're seeing here. Again, the agricultural region, the Chuska Mountains, and then some of the lakes along the mountains. You can see that much of the region here in the central portion of our image is desert or very low vegetation. So you can also click on the different pixels and get some information. So if I click on an area where there's some reds, you'll see that my classified pixel value is really low. It's 0.08. Whereas if I click somewhere here in where it looks a little more green, we can see it's a little higher, 0.3. The same thing goes for our agricultural regions. If we zoom in really far, you can see these really dark green colors. If we click on that, we'll see that this is 0.49. That's really healthy vegetation there. It's also important to note that the NDVI values show you a range of greenness in the image and doesn't necessarily tell you how much biomass or percent cover of vegetation in the image, but it's a good indicator of relative biomass. So what you're seeing here with these circles are center pivot irrigation fields. And in agricultural regions, they tend to have higher biomass, very healthy vegetation because they're monitoring it very closely as it being agriculture, as opposed to if we zoom out and take a look at the Chuska Mountains, we do see some darker greens, but they tend to be a little lighter than our managed agricultural fields. Okay, so go ahead and save your project. Always love to save along the way. Now, there is one final way in which you can do this calculation. A simpler way than using raster calculator, although I always like to show that first because it really shows you what's going on behind the scenes. You know, we talked about this in the lecture. Sometimes if you just use the one-off tools or whatever's available that's simple, you don't really see what's going on behind the scenes. So I'm just going to zoom to my layer again here. And what I'm going to do now is using the raster calculator, using the Imagery tab, we're going to use the raster functions icon. I'm going to just zoom in a little bit more here. So again, just another way to analyze your imagery. So if I click on the Imagery tab along the top, I can take a look at the raster functions icon. If you click on the down arrow here, you can open that up. Now, you may notice that you have this lovely NDVI option, which will essentially run the calculation for you. So now select the NDVI function. And within the NDVI function, you do things a little differently. You actually select the entire composite raster of interest, and it will know that, and then you will identify which bands you want to analyze within that composite image. So here, we're going to go ahead and select our clipped Landsat image. And then we're just going to tell this raster function what's the visible band and what's the near infrared band. So we know that the red band is 4, and we know that the infrared band is 5, because we did that calculation previously. You always need to double check this prior to adding the values in here. And then we're going to check this scientific output, because that's what we want, is this calculation as the output. And now we simply can just click on Create New Layer. And you can see very quickly that our new NDVI flipped Landsat image has been just added to the map. So it's a really quick and easy way to do the same thing that we just did. You will notice that it automatically applies a color scheme, and here it stretched the values all the way to -1. If in this process, it's also really important to note that what we did here was create a virtual raster. If you remember, when we actually used the raster calculator, we navigated to our exercise 3 folder and we saved the file, the NDVI new image that we created in the folder. But this, as a easy, quick way to do it, just creates what we call a virtual raster and adds that to our contents panel. So if you close your map later on, you won't actually be able to access this new image that you created. So if you're interested in saving this, you need to export the raster. So we'll just come here and close our raster function. And we're going to right click on our virtual raster that we just created. And then click on Data and Export Raster. In the export raster function, under the output raster dataset, click on this little yellow plus sign, and then navigate to your exercise 3 folder. And then we're going to save this new one as Landsat NDVI2. I'm going to use 3 since I mentioned I was using 2 for my initial one. And then click on Save. Now, all of the other options in this export raster function will remain as the default. So what you can just do here is click on Export. So now, once you do this process, you'll just have this raster saved on your computer so you can access it later on. It's always a good idea to do that, especially if you're doing a lot of different analysis and you end up not saving something along the way. It's just a great idea to have it saved so you can reference it later on. Make sure that you're organizing and saving everything really properly. Okay, so as you did with the first NDVI image, we are going to change the symbology here to make a little more sense, right? The yellows and reds aren't as helpful as we'd like for them to be. So we'll go ahead and close the export raster function. And we're going to right click on this new raster and go to symbology, just like we did initially. We're going to change the primary symbology to classify, change the number of classes to 10, and then we are going to change our values again, or our color scheme again, to that red, green, continuous. So it's towards the bottom here. We'll scroll all the way down. And again, as we did with the previous example, our first color category is actually negative, and that's going to be our water. So let's just change that red color to blue. Okay, so now you should have something that looks just like the NDVI image that you created doing it the long way with raster calculator. So you can close this here. You can explore your imagery a little closer. Again, you can remove, for example, the virtual image if you'd like, and just take a look at both of your NDVI images that you created. So you can compare these, you can run this process either way that you'd like. And that really concludes this exercise of calculating NDVI. As we discussed in the lecture, there are many different indices that you can calculate based on what you're interested in. We could calculate the normalized burn ratio, for example, if we wanted to see if there was a fire in this region. We could also take a look at the snow, or take a look at the savvy, for example, that may highlight the vegetation more clearly than we see here. But this is one example of how to use that raster calculator function in order to calculate NDVI. And again, we have that quick and easy feature there with NDVI, but you wouldn't necessarily have that for some of your other indices that you may want to calculate. So the raster calculator really does come in handy. Great, so that'll be the end for our exercise today, and we will have some time to answer your questions. So thank you.
Thanks, Amber. That was great. And just to reiterate, the use of raster calculator is, we use that a lot with remote sensing. So the more you get familiar with it, the better you'll be at doing what you need to do, not just NDVI, but of course the other indices and other things as well. Because if you think about it, raster images are just a matrix of numbers. So you can use raster calculator to do all kinds of different calculations on it. So that's fantastic. So at this point, I'm just going to go through some of the questions that were asked during this session. And then if any more pop up as we're talking here, then I'll try to answer those as well. Again, we're going to make this document available to all of you, because as you see, we have a lot of web links in here where you can access more information, because we don't have all the answers. So we often have to do Google searches ourselves to get answers to your questions. But hopefully we can provide you with enough information to answer your question. So I'm just going to start off with this first, for this first question. Do you have resources to calculate NBR, normalized burn ratio, and DNBR? So we've listed some websites here. The NBR and the DNBR calculations are pretty straightforward. Again, it's another ratio that you use. And then the DNBR is just a subtraction between a pre-fire and post-fire. But there are some websites that specify exactly what you need to do for those ratios. Okay, question 8. What is the difference between Landsat level 1 and level 2 imagery? That's a great question. And I realize we probably should have put something in the first lecture on the different levels, but essentially it has to do with processing. So the higher the number, the higher the level, the more processing. So for example, the level 2 imagery is surface reflectance. So we've listed again several websites that describe the difference between the different levels of imagery. All the imagery that we're using for these exercises are all level 2. So that's the surface reflectance products. Okay, the next question. What should be the preferred band combination to display the Landsat imagery? And so we started an answer here. The combination you choose depends on what you want to highlight in the image. And it's also kind of just what you prefer how you prefer to see imagery. Like I like to add the mid-infrared band. Some people like to look at imagery with false color, with the vegetation is red. It really is your own preference and what it is that you're trying to highlight. And we've also provided some links and some guides on different kinds of band combinations. Is the processed image downloaded from the email link? Is the processed image downloaded from the email link corrected for top of atmosphere, etc.? Yes, so I answered that earlier, and then we've answered it here. The level 2 products are pre-processed and corrected, so it's surface reflectance. Okay, what's the image pyramid? That's another great question. So the different software packages do this a little differently, but typically when it asks you to do pyramids, it's just a way of compressing the data so you can view it faster. So it doesn't do anything to the image itself. It allows you to, because image files are quite big, so they can take a while sometimes to display. And so doing the pyramid is just a way to enable you to view it faster. The next question, what time of the year or which season is suitable to download image for NDVI analysis? And the answer here is this really depends on where your image is in the world and what features you want to analyze. That's exactly right. For example, if you're interested in peak NDVI for the Northern Hemisphere growing season, you might want an image in the summer, July and August. So it really is dependent on where you are and what kind of vegetation you're interested in. Hopefully that answers that question. Question 13, if process level 2 images do not include the thermal and panchromatic bands, does it mean the process TIFF would be unusable for sharpening or thermal applications? And so Amber found a note on the Earth Explorer website. So there are some level 2 products for thermal. I'm not sure about panchromatic, and it's because they've converted the thermal data to surface temperature. So I provided a link there about surface temperature. You know, one thing to think about if you're using either the panchromatic imagery or the thermal imagery, which both have different spatial resolutions than the other bands, if you're combining those things, then your pixel values are going to change anyways. So if you're doing any kind of pan sharpening to your, to your multispectral bands, it's going to change the pixel values of those bands. So so that's one thing to think about when you're combining these sort of different spatial resolutions of imagery. Do you have more confidence in the results using raster calculator or the raster functions tool? That's a good question. I always have more confidence using raster calculator because I know exactly what's going on. However, usually the raster functions tool, especially for basic things like doing NDVI and things like that, is fine. So I think that's a personal preference between how much you trust the software and their and what I call sort of their black box approach to doing some processing. Are there resources for calculating SAVI, which is the Soil Adjusted Vegetation Index? Absolutely, and we can provide you with some web resources for calculating actually all kinds of different vegetation indices. So we'll make sure to get that information, gather that information for you and provide a list of those resources. And there are people asking, how do we access the Q&A documents? That's also a very good question. I'm guessing, well, maybe Amber, you can answer that question, where that's going to be, where this document's going to be accessible.
Yeah, thanks, Cindy. We will plan to provide the Q&A document with all of the answers and the links to the resources. We'll just post that also on the course website. We'll likely do one document for each week. So as with the recordings for the live sessions, give us about a week before we can get everything posted. We have to send the materials over to UTTC to get them uploaded to the website. But yes, you will be able to access the Q&A document at a later date, and we'll just post that to the course website each week as well.
Great, thanks, Amber. All right, well, I hope you were able to follow along with the session. Again, if you do, if you go back and kind of do the exercise on your own time, that's fine. For those of you interested in the continuing education units, you just have to complete the homework by November 30th. If you're not interested in the continuing education units, but would like a certificate, it's the same requirement. So just complete the homework by November 30th. And please, please continue to send questions to us. We got a few during the week, and we're very happy to answer anything as you as you go through the exercises or relook at the lectures or whatever during the week. If you have questions, please feel free just to drop us an email or ask us a question in the sessions next week. So maybe Amber, you can list. Looks like there's a question for the link of the website again. Maybe you could put that in the chat. Yep, she put it in the questions.
I just put it in the chat, and it's also in the questions, and it's displayed here.
Awesome. Okay. So with that, I think we'll close for the day. Thanks everyone so much for attending. Again, I wish we could see you all in person. Maybe next year. If you're interested in workshops, we can have a conversation and do some of this in person. I would really enjoy doing that and learn more about what you all are doing. So I hope you have a wonderful day and a wonderful weekend, and we will look forward to talking with you next week. Thanks so much.